morning, students. Chapter 5, Laws of Motion. Yes, today's topic is tension. Tension in a string. See, tension is one important topic. Yes, it is not given in your NCERT textbook, but to solve question, we have to know what is tension. Okay, what is tension in string and when it is produced. See, if I have a rigid support, from this rigid support, I have connected one string, light string, or we can say massless string, having mass negligible. One block of mass m is suspended. One block of mass m is suspended. So it is clear, okay? From rigid support, with the help of one string, a mass m is suspended. Mass m is suspended. Clear about this? Yes, we know that on this mass m, force mg is acting in downward direction, and due to that, this string becomes tight. Yes or no? This string becomes tight, and when this string becomes tight, we can say each and every region of this string is under tension. Clear about this? Yes. If this string becomes tight, then we can say it is under tension. If it is loose, there is no tension in the string. Clear about this? So see, here it is. When a body of mass m is suspended at the end of string from a rigid support, the string becomes tight. In this condition, every region of string is said to be in tension. Now, what is tension? Hello students, tension is nothing but one kind of contact force. How? See, here it is. At this point, electrons and protons from strings, exerts some force on electrons and protons near this region in block. Clear about this? Yes, protons and electrons in string exert some force on protons and electrons on block. And similarly, according to Newton's third law of motion, protons and neutrons from block also exert some force on string. Clear about this? And such common contact forces, it is named tension. See how it is? The proton and electron near the lower end of string exert electromagnetic force on the proton and electron of the body near contact point, and vice versa. This force is called contact force, and due to such contact forces, the body does not fall but remains stationary. Yes, this object is not falling. Why not falling? Because mg is acting in downward direction, but due to this proton and electrons of string, there is also some force on block in upward direction. And if this mg is acting in downward direction, that contact force is acting in upward direction. You know that when force acting in upward direction is equal to force acting in downward direction, total force becomes zero. Object remains in stationary condition. Clear about this? Okay. So yes, again, string exerts some electromagnetic force on block exerts some electromagnetic force on string, and due to such contact forces, this block does not fall down and it remains suspended. Clear about this? Also, see, this string becomes tight, but it does not break. Okay, so why this happens? If I am taking this region, then proton and electrons above this region exert force below this region. Proton and electrons above this region act force in region below that point. Okay, so yes, electrons and protons exert some force on these particles, as well as electrons and protons from this region exert force on these particles. Yes or no? Yes or no? Yes. And such contact forces, according to Newton's third law of motion, they are equal in magnitude and opposite direction. Contact forces are equal in magnitude and opposite in direction. So yes, due to if I say, here it is like this, in this region, these contact forces are acting in opposite direction and of equal magnitude. So therefore total force on this point becomes 0, and therefore it remains stationary, and the string does not break from this point. The string does not break from this point. Clear about this? String breaks, it means downward direction. In downward direction, force acting is more. But if it does not break, it means force acting in upward direction is equal to force acting in downward direction. Clear about this? So see, similar contact forces also act between one region and the other opposite region of every point of string. This point, yes or no? On this point, some force is acting due to this above region, also due to this above region. So according to Newton's third law of motion, these two regions will act force in opposite direction but of equal magnitude. Similar contact forces also act between one region and the other opposite region at every point of the string. They are equal and in opposite direction according to Newton's third law of motion, and this common magnitude of contact forces between two regions is called tension. Clear? Okay, and yes, tension in the string at each and every point. See, if I am taking this point, then again at this point tension is acting like this. Okay, tension is acting like this. If it is tight and it does not break, it means at each and every point is under the effect of tension. And yes, on this point tension is acting like this. If these two forces are equal in magnitude, T and T, opposite direction, then the resultant will become 0. And the string does not break from this point. Clear about this? Okay, so yes, tension in the string at every point. Yes, we have considered light string. Means due to this mass M, this string becomes tight. Yes or no? No mass of this string. So in such condition, when you are given light string, at each and every point value of tension is same. And then how to find value of tension? See, if you consider this point, on block, mg is acting in vertically downward direction. Block remains stationary as the body is stationary. Yes, at this point tension which is acting in upward direction. So yes, due to that, for this body, if I want to draw, I can draw like this. If it is mass, okay, mg is acting in downward direction. Now the body is stationary, then yes, it is clear the tension on string, it is in upward direction. It is in upward direction. Now if I draw arrow in downward direction, then is it possible that this block remains in stationary condition? No. Stationary condition means if two forces are acting, means they must be in opposite direction and of equal magnitude. If two forces are acting, it means they must be have equal magnitude and opposite direction. So yes, mg is acting in downward direction, block remains stationary. So yes, tension is acting in this direction, and we know that stationary means sigma f is equal to 0, means force acting in upward direction is equal to force acting in downward direction. So yes, here it is said to be T is equal to mg. Clear about this? And yes, most important thing is this direction of T. This direction of T, because each and every point of string is under of tension, and tension in one point, it is in opposite direction. Clear about this? Okay, so it is tension. Yeah. What is tension? What is tension in light string? Why this equation T is equal to mg? Clear about this? Now we will solve one question based on tension. So yes, you can easily understand this concept. Now we will see one example. See, it is one rigid support. First string AO, second string BO, and third string OC. These three strings are connected at point O, and from this C point, one mass is suspended having 20 kg. Mass 20 kg. These two angles are given 30 degree. Okay, you have to find in equilibrium condition. If it is in equilibrium, if this condition is in equilibrium, okay, system is in equilibrium. System is in equilibrium. System is in equilibrium. Then find tensions produced in these strings. Find tension produced in this string. See how to find. Okay, here it is. First of all, due to this mass m, mg is acting in downward direction. Yes or no? So yes, this mg is acting in downward direction, though string OC, string AO, and string BO, they become tight. And yes, tension is produced in each and every string. Tension is produced in each and every string. Yes, AO, BO and OC, these three strings are different. So tension produced in them, they are also different. So I am assuming, let tension produced in this first string, is T1. Tension produced in this string is, here it is T2. And tension produced in this string, let here it is T3. Let here it is T3. Clear about this? Clear about this? Okay. Now we have to find what is value of T1, T2 and T3. We have to find what is value of T1, T2 and T3. Okay? Okay. Now how to find? See, here it is. Here it is. Yes, the system is in equilibrium. The system is in equilibrium. It means system includes these three strings, this point O and this block M. System is in equilibrium means each and every element of system is also under equilibrium. So yes, as system is in equilibrium, system is in equilibrium, block of mass M is also in equilibrium. Okay, so yes, this block is in equilibrium. So I will draw only block. Chalo, this block M. Mg is acting in downward direction. Mg is acting in downward direction. It is in equilibrium. Equilibrium means sigma F is equal to 0. Sigma F is equal to 0. Resultant two forces must be equal to 0. Then when sigma F becomes 0, see on this block M, Mg is acting in upward direction. And in this string which is connected OC, tension is T3. So in which direction we have to consider tension? Obviously in this direction T. Obviously in this direction. Clear about this? Yes, if they have equal magnitude and opposite direction, then the force on this block will become 0. Clear about this? So yes, Mg is acting in upward direction, so tension is produced in string in upward direction. We have to consider tension in upward direction. Clear? Why in upward direction? Okay, so equilibrium condition, sigma F is equal to 0, so I can write T3 is equal to Mg. Forces acting in upward direction is equal to forces acting in downward direction. So therefore, T3 is equal to, what is value of M? 20. What is value of G? 10. So therefore, T3 is equal to, it is 200 Newton. Simple. One force, easily. Yes or no? Yes. Now we have to find tension in string AO and OB. AO and OB. Yes or no? Yes. How to find it? How to find such two forces? See, again, I will draw this point O. Okay, it is point O. Here it is OC. Here it is OB. Here it is OA. Yes or no? Yes, here it is. Okay, these two angles are given like this. It is 30 degree, I think. Yes, it is. And it is 60 degree. And it is 60 degree. Clear about this? Okay, so yes, this point O. As system is in equilibrium, this point O is also in equilibrium. This point O is also in equilibrium. Then how to write? See, this point O is also in equilibrium. It means, see, here it is. Okay, this point O is in equilibrium. Point O is also in equilibrium. So for point O, total force acting is equal to 0. Okay, now how to resolve forces? See clearly, carefully here. Tension produced in this string is T3, in this string it is T1, and in this string it is T. Okay, yes. In this string, tension is T3, that is in this direction. So what is direction of tension produced in this string and in this string? Obviously, it is in this direction T1 and in this direction T2. Remember theory of equilibrium of a particle, and when three forces are acting on particle, what is condition or what is direction of three forces? What is direction of three forces? If two forces are in this direction, then third force must be in this direction. Yes or no? Yes, it is. Okay, so yes, what see, if you observe this force is acting in downward direction, these two are acting in upward direction, then total force becomes 0. Yes or no? If I draw this arrow in upward direction, means on point O, each and every forces are acting in upward direction. There is no downward force. Then is it possible that it will be in equilibrium and total force becomes 0? No, it is not possible. No, it is not possible. So yes, for this point O to be in equilibrium condition, to be stationary, if I am taking T3 in downward direction, then T1 and T2, they must be in this direction. Clear about this? Okay. Now I am assuming it is origin, then it is x-axis and it is y-axis. Yes or no? Yes. So see, x and y. Out of T1, T2 and T3, only T3 is along y-axis. T1 and T2, they are not in x or y direction. So we have to resolve T1 and T2. How to resolve T1 and T2? See, T1, yes, it is in this direction. So I will resolve T1 in two components, one in y direction and one in this x direction. Clear about this? As T1 makes angle 60 degree with this component, it becomes T1 cos 60 and it becomes T1 sin 60. Clear about this? Okay, T1, two components, one in x direction, one in y direction. Okay, similarly, I will resolve this T2 in two components. One component in x direction and another component in y direction. As this T2 makes angle 30 degree with x axis, it becomes T2 cos 30 and it becomes T2 sin 30. Clear about this? So yes, it is figure. Okay, now see, point O is also in equilibrium. It means sigma f is equal to 0. So it means I can write the sigma fx is equal to 0. Also write the sigma fy is equal to 0. Yes or no? Yes. So now on point O, I will indicate point O here. Point O, see, first of all you have to identify forces acting along x direction. See, it is x direction and we have two forces. T2 cos 30 and T1 cos 60. T2 cos 30 and T1 cos 60. So yes, if sigma fx is equal to 0, we know that on point O, force acting on right hand side is equal to force acting on left hand side. If these two forces are having equal magnitude and opposite direction, then resultant force becomes 0. Then resultant force becomes 0. So yes, as sigma fx is equal to 0, two forces are acting along x direction. So I can write T1 cos 60 is equal to T2 cos 30. Clear about this? Now we know values of cos 60 and cos 30. So yes, here it is T1 cos 60. Cos 60 means here it is 1 by 2. Cos 60 means here it is 1 by 2. Okay, is equal to T2 cos 30. Cos 30 here it is root 3 by 2. Cos 30 means here it is root 3 by 2. So yes, T1, 2 and 2 cut. So T1 is equal to root 3 T2. T1 is equal to root 3 T2. We obtain the result. Clear about this? Okay. Now, sigma Fy is equal to 0. Sigma Fy is equal to 0, it means what? Yes, it is y direction. Along y direction, numbers of forces acting are T1 sin 60, T2 sin 30, and here it is T3. T1 sin 60, T2 sin 60. They both are acting in upward direction, and this T3 is acting in downward direction. These two forces are acting in upward direction. This force is acting in downward direction. If their magnitudes are equal, direction opposite, resultant force becomes 0. So how to write? T1 sin 60 plus T2 sin 30 is equal to T3. Now to value T1 sin 60 means it is root 3 by 2 plus T2 as it is sin 30 means it is 1 by 2. And what is value of T3? Yes, T3 is equal to 200 that we have obtained. Clear about this? Okay. So yes, here it is root 3 T1. 2 common plus here it is T2. 2 common, and if you multiply this side, you will get it is 400. Any doubt? Any doubt? Okay. Now see, T1 is equal to root 3 T2. Simple. T1 is equal to root 3 T2. So I will put this value here. Root 3. T1 means it is root 3 T2. Any doubt? Okay. Plus T2 is equal to 400. You know that root 3 into root 3, it becomes 3. So it is 3 T2 plus T2 is equal to 400. 3 T2 plus T2, 4 T2 is equal to 400. So therefore T2 is equal to 100 Newton. T2 is equal to, it is 100 Newton. Easy. Okay. How to find T1? Yes, put value in this equation. T1 is equal to root 3 into 100. Root 3 into 100. And yes, what is root 3? So T1 is equal to is 1.73 into 100. So T1 is equal to it is 173. T1 is equal to it is 173. Clear about this? So yes, important thing is this free body diagram. This free body diagram. Okay, how to draw this diagram? How to take directions of tension? T3 is in downward direction, then T1 and T2 they are in upward direction. Clear about this? Clear about this? So yes, you have to imagine situation. Okay, when it is possible, okay, this point O will be in equilibrium condition. So yes, it is one question based on tension. Okay, how to find tension produced in strings.